Number 14. Prove using algebra that n plus 1 cubed minus n cubed is odd for all numbers where n is a natural number, meaning a positive integer. So in order to prove that n is odd for all integers, we would have to check this for both even numbers as well as odd numbers. So what we can do is we can start by checking it for an even number. So assuming that n is equal to an even number would imply that n is equal to a multiple of 2, so we can call it 2m. If we then substitute 2m into all the places where we've got n, we can rewrite this as 2m plus 1 cubed minus 2m cubed. If we then expand the bracket, 2m plus 1 cubed means we are multiplying this by itself 3 times, and minus 2m cubed, which can be rewritten as 2 cubed, which is 8, and m cubed, so 8m cubed. We can then start by expanding the first two brackets, which is 4m squared plus 4m plus 1, and we've still got the second bracket and the minus 8m cubed. We can then expand this further as 8m cubed plus 4m squared plus 8m squared plus 4m plus 2m plus 1, and we've still got the minus 8m cubed. We can then collect all the like terms, and we can see that we've got 8m cubed minus 8m cubed, which would cancel out. We've then got the squared terms, which are 4m squared plus 8m squared, which gives us 12m squared. We've got the n terms, which are 4m plus 2m, which would be 6m, and we've got the plus 1. Because we're trying to prove that it is odd, we can now factorize the first part of the equation by factoring 2 out. So this would give us 2 bracket 6m squared plus 3m, and then we've got the plus 1. So because we're multiplying this bracket by 2, this means that this would be an even term. And because we're adding 1 to the even term, that means this would give us an odd number. So we have shown that when n is even, this expression would always give us an odd number. We can now check the same for when n is an odd number. So assuming that n is an odd number, this would imply n would be equal to an even number 2m plus 1. If we now substitute 2m plus 1 wherever we've got n, the first bracket would be 2m plus 1 cubed minus 2m plus 1 cubed. We can further write this in a simpler way as 2m plus 2 cubed minus 2m plus 1 cubed, which means that we are multiplying this bracket by itself 3 times. And as we can see in the first part of our working out, we've already worked out what 2m plus 1 cubed would be, which is this whole expression here. So we can just substitute that rather than expanding this again. So expanding the first two brackets would give us 4m squared plus 8m plus 4, and we've still got the second bracket that we need to multiply it with, and we can now apply the negative sign to this bracket to give us minus 8m cubed minus 12m squared minus 6m minus 1. We can then expand these two brackets once again to give us 8m cubed plus 8m squared plus 16m squared plus 16m plus 8m plus 8. And we've still got the minus 8m cubed minus 12m squared minus 6m minus 1. We've then got the 8m and the 8. We've then got the 8m and the minus 8m, which would cancel out. Looking at the terms that have m squared, we've got 8m squared plus 16m squared minus 12m squared, which would give us 12m squared. We've then got the m terms, so 16m plus 8m would be 24m, minus 6m would give us plus 18m, and then we've got the plus 8 minus 1, which would give us plus 7. We can then split the 7 and rewrite this equation as 12m squared plus 18m, and we can split the 7 into plus 6 plus 1. So 3 terms in this expression are divisible by 2, so we can factor 2 out and write this as 2 bracket 6m squared plus 9m plus 3, close the bracket and put 1. So as we can see, here as well, we have a multiple of 2, meaning that this is an even number, And when we add 1 to an even number, we always get an odd number. So because we've checked this calculation, both for when n is even as well as when n is odd, and for both calculations we saw that we were getting an odd number, we can now say that therefore n plus 1 cubed minus n cubed is odd for all numbers where n is a natural number.